You know that split-second gap between tapping connect and your Wi-Fi springing to life? That's DHCP running a 4-step handshake in milliseconds, assigning your device an IP, subnet mask, gateway, and DNS on the fly. Without it, you'd be stuck manually typing addresses for every device, a slow, error-prone nightmare. Most IT beginners have no idea it's even happening. By the end of this video, you'll be able to recite the DORA process and troubleshoot it like a pro. DHCP stands for Dynamic Host Configuration Protocol. Think of it like a city hall clerk who hands you a key and a street address the moment you move into a new apartment. Except the clerk is a server. The key is an IP like 192.168.1.50, and it all happens in under a second. Before DHCP, administrators had to manually set static IPs, a slow, error-prone task. DHCP evolved from an old protocol called BUP in the early 1990s, and it's now defined by RFCs 2131 and 2132, essentially the rulebook that keeps IP leasing fair and efficient. To appreciate DHCP, you have to understand the mess it replaced. Before DHCP, you'd manually type a unique IP, subnet mask, default gateway, and DNS servers on every single host. A slow, error-prone process that required a spreadsheet just to track who had what. One accidentally duplicated IP would knock both machines offline. DHCP flips that. A server hands out IPs automatically with a lease, so conflicts are virtually impossible, and you can plug in a new device and be online in seconds. That's why DHCP is non-negotiable in every modern network. The core of DHCP is a 4-way handshake, memorized by a simple acronym. DORA. Discover, offer, request, acknowledge. It's a conversation where your device shouts out to find a server. The server offers a lease, you request that exact lease back, and the server confirms it. All 4 steps happen in the blink of an eye whenever you connect to a network. Knowing DORA isn't just trivia, it's your troubleshooting anchor when no internet pops up. The first step is Discover. Your client yells into the void by sending a DHCP Discover packet with source IP 01.0.c.2.0.0.0, since it doesn't have an address yet, and destination 255.255.255. 2UI52I55, the broadcast address that reaches every device on the local subnet. It uses a UDP broadcast on the well-known DHCP server port. Every DHCP server on that subnet picks up the broadcast. If no server answers, the client waits, then retries a few times before falling back to an APIPA address in the 169.254.xx range, the annoying self-assigned IP you see when things aren't working. That broadcast scope is critical. DHCP Discover never leaves the local subnet unless a relay agent forwards it. But here's the part that trips up newcomers. After a server sends an offer, the client still has no IP. It's just window shopping. The DHCP server reserves a proposed IP from its pool and responds with a DHCP offer packet. The offer contains the tentative IP, subnet mask, lease duration, and options like default gateway and DNS. If multiple servers exist, they all may send offers, and each one is valid. The client hasn't committed to anything, it's still unconfigured until the next step. Common mistake. Assuming the client already has an IP at this point, it absolutely does not. Now the client chooses its favorite offer, usually the first one it saw, and fires off a DHCP request packet. This packet tells the winning server, yes, I'll take that address, and also lets the other servers know they can release their reserved IPs back to the pool. Beginners often think the request goes only to one server. In reality, it reaches all servers on the subnet thanks to the server identifier field. Finally, the chosen DHCP server locks in the lease by sending a unicast DHCP pack directly to the client's MAC. This packet cements the committed IP address, subnet mask, default gateway, DNS servers, lease duration, and renewal timers. Once the client receives the ACK, it configures its network interface and is officially on the network. If the client never gets this acknowledgement, maybe the server ran out of addresses, it stays unconfigured and might eventually fall back to an APIPA self-assigned 169.254 address. Without that ACK stamp, the handshake is incomplete. DHCP relies on two UDP ports that must be open, one for the server and one for the client. Why UDP instead of TCP? Because DHCP is connectionless. The four-step exchange needs to be lightning fast, and UDP's fire and forget model is perfect. Firewall rules blocking these ports are the top cause of DHCP server not responding, errors. And here's a classic beginner mistake. Assuming both ends use the same port, they don't. You've just walked through every stage of the DHCP handshake. Here's a quick check to make sure it sticks. Can you recite the 4 DORA steps in order? If you said discover, offer, request, acknowledge, you've got it. This sequence is the foundation for troubleshooting any no IP issue. Next time, you'll know exactly where to look. When you run ipconfig, all on Windows, you're seeing the actual DHCP options your machine received. One option hands you the default gateway, the router that gets packets out of your local network. Without it, you'd have a valid IP but zero internet. Another option gives you DNS servers. Break that, and even Google won't load. There's also an option that sets the domain suffix so you can resolve short names inside your company. And the lease time option tells you exactly when this IP expires. DHCP is secretly a full network auto-configuration service, not just an IP dispenser. A DHCP scope defines the entire pool of IP addresses the server can hand out. For example, a scope from 192.168.1.10 to 200 covers roughly 200 addresses. The subnet mask keeps everything on one network. The scope must match the server's own subnet, or you need a relay agent. Exclusions carve out addresses DHCP must never touch. The router at point 1, a few static servers, and the managed switch at 254. If you exhaust the scope without realizing it, new devices will scream DHCP server not responding. This is why you plan the range before the office grows. Every DHCP address comes with a lease. It's not yours forever. When the lease is about half used, the client tries to renew directly with the DHCP server. If nothing comes back, as the lease nears expiration, the client broadcasts a rebind to any server that will listen. Still no answer? The lease expires and Windows auto-configures an APIPA address in the 169.254 range. No default gateway, no internet. As for lease duration, Windows Server defaults to 8 days, while home routers typically use shorter leases, often a day or less. The process is completely silent until it fails, so you'll never notice it working. When DHCP fails completely and the old lease has expired, Windows gives itself an address from the 169.254.0.016 block. This is APIPA, Automatic Private IP Addressing. It lets you talk to other APIPA devices on the same switch, but you get no default gateway. That means no internet, no network shares. The moment you spot a 169.254 address in ipconfig, you know it's not a DNS issue, it's a DHCP failure. Check whether the DHCP server is running, whether the scope is full, or if the cable is even plugged in. APIPA is your built-in alarm bell. Learn to read it, and you'll cut troubleshooting time in half. Here's what nobody tells you about DHCP. Reservations are not just for printers. They're the cheat code to a stable network. A reservation binds a MAC address to a specific IP inside the DHCP scope, so the device always pulls the same address but still gets all the other DHCP options. No manual static IP typos, no forgotten assignments. The mistake almost everyone makes. They reserve domain controllers and file servers and stop there. IoT sensors, smart TVs, PTZ cameras, these things reboot and grab a random IP, breaking your monitoring dashboards and firewall rules. Reserve anything that acts like a server but doesn't have a proper management interface. Do it once, and your network stays predictable forever. Let's lock this printer down right now. Log into your router or DHCP server console. I'm using a typical home router at 192.168.1.1. Find the connected devices list, note the printer's MAC address, then go to the DHCP reservation page. Click Add reservation, type 192.168.150, and save. That printer will now always get 50, even after a power cycle. In a Windows Server environment, you do the same inside the DHCP MMC. Right-click Reservations. Choose New Reservation. Pop in the MAC and IP. One huge thing to remember: the reservation is tied to the MAC address. If you ever swap the network card or NIC, you'll need to create a new reservation for the new MAC. Exclusions are the IP addresses you tell DHCP. These are already taken. Don't give them to anyone. The router at point 1, your domain controller at point 10, your switch at point 254, all hand configured, so they must be excluded. If you set a static IP on a server but skip creating an exclusion, the DHCP server has no idea that address is occupied. It could hand the same IP to a laptop, creating a duplicate IP conflict that's painful to debug. Always create the exclusion first. In Windows DHCP console, expand your scope, right-click Address Pool, and add an exclusion range. It takes 10 seconds and saves hours of confusion later. Pause the video and answer. Which mechanism makes sure a printer always pulls 192.168.1.50 without you ever touching the printer? When do you really need a static IP? If other devices must always find a service at a known address, your router, domain controller, core DNS server, go static. For everything else, DHCP with reservations is faster and safer. In a typical enterprise, most endpoints use DHCP, while a smaller portion are infrastructure boxes where a changed IP would break something. Document every static assignment and pair it with a DHCP exclusion. And never rely on memory. One undocumented static IP is all it takes to ruin a Tuesday afternoon. Here's the reality. Home networks run on DHCP almost exclusively. Your phone, laptop, smart speaker all grab addresses automatically. Small businesses typically use DHCP for the vast majority of endpoints, keeping only a handful of static IPs for printers and a server. Enterprise campuses lean hard on DHCP with reservations, automating the rest while keeping critical services predictable. The big drop is the data center, where only a minority of devices rely on DHCP. Most servers are assigned static IPs for firewall rules and long-term stability. So if you think a professional network is all static, the data says otherwise. DHCP, properly configured, is the professional way. Before you reboot, run ipconfig all. This shows your DHCP server's IP, when you got the lease, and exactly when it expires. That's the first diagnostic stop for any connectivity mystery. The common mistake? Assuming your IP is permanent when it's actually borrowed on a timer. The two commands every help desk tech knows. ipconfig, Josh release, drops your IP, and ipconfig, renew. Kicks off a full DORA process from scratch. This fixes stuck leases, the dreaded APPA address, and saves you from unnecessary reboots. Always try this first. If someone manually set a static IP, you won't get a DHCP address. Navigate to IPv4 properties and flip both IP and DNS from manual to automatic. Then hit ipconfig all to verify the server handed you a fresh lease. Forgetting DNS is the classic half-fix. You disable the built-in DHCP server when converting a router into a pure access point. Otherwise, you'll get two competing DHCP servers handing out conflicting IPs. Just make sure there's another DHCP source on the network first, or your devices won't get addresses at all. You can still manually reserve static IPs for printers or servers. DHCP snooping turns your switch into a bouncer. It blocks DHCP server replies from any port that shouldn't be hosting a server. Configure it on every switch that touches user traffic, and you'll stop rogue routers from hijacking the whole subnet. Without snooping, a rogue DHCP server slips in an offer with a malicious gateway and DNS. Every client that accepts now sends traffic through the attacker. With DHCP snooping, the switch instantly drops any server reply from an untrusted port before it ever reaches the victim. Defense in depth. Start with the router lights. Then push a fresh DORA with release, renew. If that still fails, hop onto a second device. If it gets an IP but the first doesn't, you know the problem is local to the device, not the server or scope. DHCP client service stopped is a silent killer. You'll see unidentified network and pull your hair out. After verifying it's running, ping the server. If that works but DHCP still fails, suspect a firewall or a full scope. That 169.254 number is the universal cry for help. It means Windows tried DHCP, got nothing, and gave up. The fix is one command pair away. ipconfig, release, and ipconfig, renew. You just went from zero to troubleshooting DHCP like a pro. Now grab the free IT career roadmap in the description. It plots your next moves from fundamentals all the way to engineer. DNS, subnetting, VLANs. That's where the real fun starts. Subscribe so you don't miss a single skill.